Hello everyone. This is still lesson 5.4, sum and difference identities, and these are the identities that I explained in the previous video, right? So now we were just evaluating in the first part. The second part, they want to find the exact value of each expression. Okay, so find the exact value. Here it's kind of the opposite. They gave me it expanded and I need to condense it. I mean, now instead of being on this part, I'm on this part, which is easier. I just need to go back. I just need to think this is a tan and it has minus in the numerator and a plus in the denominator. Which case is this? A minus and a plus in the denominator. So it's a difference identity tan A minus B. So I'm just gonna cut it short and it will be tan 43 minus 13. And tan 43 minus 13 is tan 30. And do we know tan 30? Yeah, we know tan 30 because tan at 30 is y over x. Sorry for the camera. Y over x. So half over root of 3 over 2. Half over root of 3 over 2. This cancels this as we did before. 1 over root of 3 times root of 3 over root of 3. So the answer is root of 3 over 3. Again, you can check with a calculator. Okay. Question number 12. Which identity is this? It's something that has cosine, cosine, sine, sine. We said, who does cosine, cosine, sine, sine? The cosine, difference and sum identities. And in the cosine, we changed the sign. So, awalan, I knew it's a cosine. And from the plus, I knew it's a minus. What are the angles? These are the angles. So, I would just write it as cosine 5 pi over 12. And the opposite sign of this is minus pi over 4. And if you subtract these, you're gonna get cosine pi over 6. Yani cosine at 30. And cosine at 30 is root of 3 over 2. And this is the answer. Here, again, it's a sine, cosine, cosine, sine. Who does this sine, cosine, cosine, sine? Sine, cosine, cosine, sine. It's the sine function. And in the sine function, it's the same, or I mean the sine identity. It's the same sign. So awalan, I know it's a sine and I know it's a plus. And where are the angles? 15 and 75. So I'm sure it's sine 15 plus 75. I will copy the same sign. So it's the same as sine 90. And sine at 90 upwards, the sine at 90 is 1. And this is the answer. See how this is the use of sum and difference identities. I don't know how to deal with 15 and 75, but I know how to deal with 90. I don't know how to deal with 5 pi over 12, but I know how to deal with pi over 6. Type again, it's a sine, cosine, cosine, sine. So it's a sine function with a plus in between. And what are the angles? Pi over 3 and pi over 12. صح? صح. If you add these, make the denominators equal and simplify, you will end up in sine pi over 4. And sine in pi over 4 in the first quadrant, first quarter, is root of 2 over 2. So here I have a cosine function. Why? Because it's a cosine, cosine, sine, sine. So it's a cosine function, and in the cosine function, it's the opposite sign. So I'm going to use cosine 40 plus 20. And that's cosine 60, and cosine 60 is half. And this is the answer. So I think here is shorter than the previous questions and thinking about the angles and all that. Over here, it's very, very short. So this one is a tan where it has a plus in the numerator and a minus. So it's going to be tan 48 plus 12. One of the questions will trick us here. This has to be like this one. It has to be plus and it has to be minus in the denominator. If originally the function was an addition. Okay, I'll show you the other question in a while. So it's tan at 60. And what is tan at 60? Again, y over 6 at 60, root of 3 over 2, this one, over half. Whenever we have the root of 3 upwards, the answer will end up in root of 3, and tan is positive in quadrant 1 as we know, and it's pretty good. The coming questions are asking us to simplify. How will I simplify? Let's see. Again, this is the tan difference identities, right? It's this one. When I have a minus up and a plus down and it's tans. So I know that the question was originally tan 2 theta minus theta. If you can evaluate, evaluate. If you cannot, you would just leave it like that. Okay? So tan 2 theta minus theta is tan theta, and this is the answer. If I got a number over here, I would evaluate it. If I can use other identities to simplify more, I will, but over here I'll do nothing. Okay, so this is which identity? Cosine, cosine, sine, sine is a cosine, and there is a plus here, so it has to be a minus. And it's a cosine because the cosine is the one that does cosine, cosine, sine, sine. So it's a cosine x minus pi, sorry, الأول pi over 2 minus x. See, what did I get? You remember what is this? This is co-function identity. So I can do a further step over here and write the answer as sine x. Okay, this one, it's sine, cosine, cosine, sine, so it's sine, and the sine is the same sign. I will just copy the same sign, and here one angle is 3y and one angle is y, so your answer is sine 4y, and you cannot do anything to that, right? Again, cosine, sine, sine, cosine, it doesn't differ, sine, cosine, wala cosine, sine, because it's a multiplication. Multiplication is commutative and associative. There's no problem to switch them. So anyways, it's still a sine rule, right? It is still a sine one. So I can say it's sine 2x, the same sign, minus x. Or I can say that the answer is just a second, number 20. Yeah, the answer should be sine 2x minus x, so it has to be sine x. Okay, so the answer is sine x. Okay, and what else? Okay, this one is the one that I told you is a little bit tricky. Why is it a little bit tricky? If you look at the numerator only, you might think that it is some, this one in here, but this one down, it's 1 minus. And actually I don't have 1 minus here, بالعكس and I have the multiplication minus 1. How can I make it 1 minus the multiplication? I can make it by putting a negative outside. Remember that, putting a negative outside and then switching them. Switching the numerator or the denominator. So I need to switch the denominator over here. One of them only switches places or switches signs and change. This becomes negative, this becomes positive. And I'm gonna leave the numerator as is, right? Plus tan theta. If I have the question like this, then probably it's this, tan a plus b. But I have a negative outside, I'm gonna keep it, and it's gonna be tan 6 theta. Negative tan 6 theta is the answer. Okay, I'm going to some verifying each co-function identities. These are co-function identities that we took, and today, according to the difference identities, I can prove them in a second. How can I prove them in a second? Okay, if I'm thinking of using the tan difference identities directly, I will face a problem. This one, I'm sorry. I will face a problem that tan pi over 2 is undefined. Tan at 90 is undefined. Okay? If you're thinking this way, tan at 90 is 1 over 0, and I cannot do that. So I will not go to this way. I'll go to another way to prove the identities. And these are all, as I said, co-function identities. If I change the question, and I'm using a quotient identity because tan is sine over cosine. If I do this, now let's use the sign difference identities. It's going to be sine pi over 2 cosine x, the same sign, cosine pi over 2 sine x. صح? And here it's cosine cosine, cosine pi over 2 cosine x, and the opposite sign, so it's going to be a plus sine pi over 2 sine x. And let's evaluate. Let's get a sine pi over 2. Sine at the 90 is 1. So I can say it's 1 times cosine x minus cosine at pi over 2 is 0. So 0 times sine x is going to be 0. Cosine at pi over 2 again is 0. So 0 times cosine x is 0. Plus sine at 90, we said it's 1 times sine x. What did you end up with? You ended up with cosine x over sine x. And what is cosine x over sine x? Cotan x. And here you proved this cofunction identity. I just want to display as much as possible different questions for you to become like, you know, advanced in identities or think in a more open way. So for this one, again, I'm not going to work on cosec x. I'm going to work on sec pi over 2 minus x. And I don't have difference identities for sec. I can use 1 over cosine pi over 2 minus x. So it is 1 over, in the cosine we do cosine cosine, cosine pi over 2 cosine x, and the opposite sine, sine pi over 2 sine x. Okay, cosine at 90, I didn't move right or left, is 0. So 1 over 0 times cosine x plus sine at the 90 is 1 times sine x. This is gone. I ended up with 1 over sine x, and that is cosec x. Okay, this one, cotan pi over 2 minus x. I don't have difference identities for cotan. I'm going to change it to 1 over tan pi over 2 minus x, and that can be 1 over tan. Oh no, I have the same problem over here. I cannot do tan pi over 2 because tan pi over 2 is undefined, so I'm going to use something else. I'm not going to use that. Actually, I'm going to use this is cosine pi over 2 minus x over sine pi over 2 minus x, and this is easy for me. But for you, cosine is cosine cosine, so cosine pi over 2 cosine x, and then the opposite sign, sine pi over 2, sorry for the camera, and the sign is sine pi over 2 cosine x, and the same sign, cosine pi over 2 sine x. So let's evaluate and simplify. We will end up in a tan x for sure, because this is a cofunction identity that we know it is true. What is cosine at 90? Cosine at 90 is 0 because we didn't move right or left. Cosine x, so this is gone. Plus sine at 90 is 1, so 1 times sine x all over. Sine pi over 2 is 1 times cosine x. I cannot evaluate it. Cosine pi over 2, I can evaluate it. It's 0 times sine x, so this is gone. I'm left with a sine x over cosine x, which is equal to tan x. And here we verified. P, verify reduction identities. We do not take reduction identities, but still, these are all identities and they're called reduction, kind of reducing them, reducing this to this and this to that and that to that. The three are true. How can I prove them? I can prove them here with difference identities for a cosine. Cosine is cosine cosine, so cosine pi, cosine theta. The opposite sign, sine pi, sine theta. I can evaluate this, I can evaluate this, I cannot evaluate the others because I don't know what is theta. Cosine at 180 is negative 1. So negative 1 times cosine theta, probably one of them has to be 0. Sine at pi is going to be 0 times sine theta. So this is gone and ended up in negative cosine theta, and here I proved it. This is sum of cosines. So cosine 2 pi, cosine theta, the opposite sign, sine 2 pi, sine theta. Cosine at 180 is 1 times cosine theta. Sine at 180, sorry 360. خلاص أنا بدأت أخرف. 360. So 0 times sine theta, it's gone. You ended up in cosine theta. Regarding this one, it's sine. So in sine, we use sine cosine, sine pi, cosine theta. The same sine, cosine pi, sine theta. Sine at 180 is 0 times cosine theta minus cosine at pi اللي هي 180 is -1 times sine theta. This is gone and you ended up in sine theta, and here I proved it. Find the solution to each expression. Okay, so here they want a solution. Solution means they want to know what is theta. So let's go with the flow. This is a sum for a cosine and this is a sum for a sine, and there's a subtraction between them. You have to be very careful with it. And they're setting it equal to 0. When is this equation equal to 0? أولا cosine, we do cosine pi over 2 صح sine x, and then the opposite sign sine pi over 2 cosine x minus open bracket. For the sine we go sine pi over 2 sine pi over 2, no, it's the opposite, sorry. Cosine is the one that does cosine cosine, cosine cosine, sine sine. So cosine is like this and it's the opposite sign. Like in sine is sine pi over 2 cosine x, the same sign cosine pi over 2 sine x. كده مظبوط؟ طيب مظبوط. Cosine at 90 is 0. So here I have 0 times cosine x and this is gone. Minus sine at pi over 2 is 1 times sine x minus. Okay, take care that the minus will affect this and will affect this. Okay, so minus sine pi over 2, sine at pi over 2 is 1 cosine x, and here this is going to be a minus cosine at pi over 2 is 0 times sine x. So I will discover that this is gone and this is gone and equal to 0. Right, let's see how can I think of this question if I were you. The question is saying negative sine x is equal to, I'm gonna send this to the right side, is equal to cosine x. What is this x in which negative sine x is equal to cosine x? Oh, sine x is equal to negative cosine x. It means when are the sine and the cosine the opposite signs. يعني مثلا أنا basically I would think of root of 2 over 2 and negative root of 2 over 2 because there's nothing else where they are exactly equal but opposite signs. صح؟ دايما ما كانوش بيبقوا equal. They're equal here. They're opposite equal but opposite signs here. They're equal here and they're equal but opposite signs here. Otherwise they were never equal. So I know this is a little bit hard to understand, but in here I can say that cosine x is equal to negative sine x. صح? And here I can say that cosine x is equal to negative sine x. So I don't have an option except 7 pi over 4 and 3 pi over 4 where they are equal but opposite signs. Okay? X is equal to 3 pi over 4 or 7 pi over 4. This is the only option that makes them equal but opposite signs. There's nothing here. This is from the other paper. Okay? I will show you more of these, how to solve. Over here I have a cosine pi over pi plus x and cosine. Okay, we can make it shorter thinking that it's 2 cosine pi plus x equals to 1. So I'm going to do cosine adding identities or sum. It's cosine pi cosine x opposite sign sine pi sine x equal to 1. What is cosine at 180? Cosine at 180 is negative 1. So negative cosine x, I change this to negative 1. Minus sine at 180 is 0 because I didn't move up. Sine x equals to 1. So this is gone. And I am left with negative 2 cosine x is equal to 1, or cosine x is equal to negative half. When is cosine x equals to negative half? I need to know x. When, okay, here everybody's positive, here tan is positive, so probably cosine is here, and here I can find the negatives because cosine is positive here. Negative half ادي واحدة عند 2 pi over 3. Cosine is negative half, cosine is negative half at 4 pi over 3. So here 4 pi over 3 and 2 pi over 3. Pi over 3 and 4 pi over 3 are the answers. If, sorry, someone is thinking, okay, they have coterminals because the circle keeps repeating. I forgot to tell you something regarding this question. Where did I start? The question said find the solutions to each expression on the interval 0 to 2 pi. معناه best one round, we're not going more rounds, right or left or anywhere. So only answers on the unit circle will fit this. And I didn't do inverses. Okay, I did not say cosine negative 1 is equal to negative half. So we think that cosine is only from 0 to 180. ولا الكلام ده. I just left it cosine x is